You're young and dumb.
Why do you need 6 courses? She said you have to be 6 I think she said it was 6 courses. For a paper. There's 2 each paragraph. There's 2 each paragraph. It's 4 paragraphs.
But if you have the bullshit, then it will be
All right. So what do we think? Which one of these doesn't fit?
Hey,
Why?
because it's all scattered apart.
It's really loose.
All the other ones are like more together.
It could be B, C, D.
This is a really weak correlation.
The D.
They are really spread apart.
C would be the next one, right? Because you got.
Why?
If you put a line through it,
Uh-huh.
the ones that's, I don't know how to explain.
That's okay.
Them ones
Uh-huh.
on the left side,
Yep.
it'll be far away from the line.
Yeah. If we try to do a line of best fit on C, it wouldn't actually be a line. It would be very, very curved. So this has a non-linear relationship. So, I wonder if there's more than one answer possibility here. Almost like we need to have evidence and
Yeah, D, 'cause
reasons.
it's-
Why might D be a reason that somebody picks?
It's shaped the other way.
It's negative.
It would have a negative correlation.
All the rest of them are positive.
The rest of them are vaguely positive. Even our really weak one, if I did a line of best fit, it would probably be around there. It's still mostly positive. But D has a negative relationship. Does anybody see something in B as to why we could have picked B?
B, there's nothing really wrong.
They got a dot right there.
It's not that there's anything wrong with these. It's not that there's something wrong. It's just reasons why. So why might someone say that B would be the weird one up here?
Because that's some random outlier.
It has a random outlier.
Yeah, the one all the
This one random dude over here.
you just been there for fun.
We have a random outlier. It's the only one that really seems to have an outlier.
The odd one out.
So that could be that we're talking to kindergartners and randomly Michael Phelps walks in the room. Like that's all. That would throw a whole lot of data really, really far off. Okay, so there are, my turn to talk. There are legitimate reasons why you could have had your opinion be any of these. And that is going to be true for a lot of the things we have. When I ask you to form an opinion, there may not be one right answer. There might not be a right answer. I could have legitimately picked any one of these to say it's the odd one out. This one doesn't fit because of this. This is why the reasons are so important. You have to be able to back it up. You have to be able to back it up. You've got to show evidence. The evidence is what's important. Your opinion's well and good, but I need to know why. Your opinion is important, but your evidence is more important. So you've got to be able to have evidence. So we're going to be working at finding evidence and what we can do to find that evidence. And we're going to start looking at these. I've already used the word once or twice, but what were those lines that I drew in there? Yeah. So these lines in here, these are our correlation lines. Or what else do we call them sometimes?
We call it.
We don't call it that. Uh-huh. What might we call this? What else might we call it aside from correlation line?
Congruent?
No. Huh?
Oh, no.
No?
I was looking at C.
It could be a line of...
Congruency.
No. Where are y'all getting congruent from? Like you trying to pull up some geometry words. Want to say that again a little bit louder?
He said I've taken this class twice already.
No, you haven't.
No, I know, that's a joke. Line of,
That's what I'm saying.
Mm-hmm.
no, it's not congruency. Can I get some
Not
help?
congruence.
You're the oldest. You're the oldest.
Best.
So?
The line of best fit. Or the best fit line.
I knew that.
Regression line. We don't usually use regression here all that much, but we're going to be working with lines of best fit today.
Wow.
It's the line we draw through the scatter plot, like these. We're going to be making these today.
I use my brain for nothing, basically.
No, you were just trying to pull up vocab from forever. All right.
Back in my day, that word was a lot.
So we're going to be using some data from your book. Let me clear that off.
It's sad because I don't have my book with me.
Well, luckily, if you got your computer, I've got this data set available for you. And in fact, doing it on the computer is going to be way, way, way easier.
You do have a computer.
No, it really is. Otherwise, you get to draw the scatter plot by hand. And then find your line of best fit by hand. And find your equation by hand. I know you could, but your equation is going to be way more accurate if you use a computer. So this is the data set in your workbooks for page 93 through 95. It has a couple of, okay, 93 and 94. It's not actually 95. It has a graph in there, like a graph paper, so you could draw it by hand. So if you don't have your workbook with you, you can do it by hand. It's just definitely the hard way. It's really not. Because we're going to draw our scatter plots. And in fact, we're going to need 3. And then you're going to find your line of best fit and the equation for it. Yeah, let me read you back. Give me a few minutes. Yeah. Let me get everybody going on what we're doing here first. So what we're looking to do today is we are looking to find out how much we should sell our used car for. So we've got that Jane is looking to sell her car. She's got a Subaru Forester, but she doesn't know what to price it. And so she found a whole lot of other similar cars for sale. So she's got the same model, just different ages, different mileages, and what they sold for. So what we're going to do is we're going to try and see if we can figure out how much she should list her car for to get the most bang for her buck, but also so that someone will buy it so it's not overpriced. So all this data is on page 93. It's this exact same table. So you can do it by hand. Or you can go onto the Canvas page and use the data set link and pull it up on Codep with all the data right there. So when we're looking to see if we could figure out what we need to price the car, which of these 3 data pieces would be most helpful to compare? We've got age, mileage, and price. What things should we compare here? Y'all, this is how you would find the price of the car if you're trying to sell your car. And not just trying to sell it to CarMax and get like $500.
Mileage. Age.
Mileage versus age, will that help me price my car?
Yes.
No.
Because does mileage versus age give me any relationship with the price?
Oh, no.
Oh, I can.
Not mileage versus age.
Mileage and age.
What about mileage and age? So if let me grab,
The age of the car determines the
I don't
price.
drive your
Oh,
2002
hang on. So if I come into the Codep set and I grab my mileage and my age, how does this help me figure out what to price my car at? If my car is right here, what's my price?
14,000.
Zoom in so we can actually see things. So if I put this together and I show you that maybe my car is right about here, where my little arrow is.
9.8K.
Maybe my car is 120,000 miles and 10 years old, so I'm right here on this laser dot. What would I put the price as? Does it have information about price here? No. So maybe what should we compare instead? We could do age and price. Come on. So I could swap this age out for price. Or, guys,
Excuse me.
What is that?
Get some tissue.
all I got is paper towels that are knee high on the summer shelf. Or we could do price versus, let me get people going on this first. Price versus mileage. Oh, I did that on both. Price versus age and price versus mileage. Give me a second. Let me get people working on this.
My bad.
So how would these, guys, I am trying to help you. This is stuff we're going to be using in our project in a week and a half. Please stop talking over me. I'm really sick of the disrespect I get in here. We got a lot of people staring at their phones. We have a lot of people with either no computer or no workbook out or both. This is an elective class, which means if you're in here, you chose to be in here, and if you're in here and failing, you're wanting an F on your transcript. And I have a surprising number of Fs in here. Just saying. I'm not calling people out individually, but this is an elective. You don't have to take this class. We had a whole lot of conversation about that first couple of weeks. You chose to be here. Because I told you if you didn't want to be here, you could talk to your counselor. And you didn't, which means you either one, didn't listen to me, or two, didn't believe me. You chose to be here. Stop treating me like I am your babysitter. You have things to do. This is a class. It goes on your transcript. It's a grade. And we have a project that uses this software next week that goes in as a test grade, which means we might want to know how to use the software we're using on our test. I've been trying to show you guys this stuff for like 3 weeks now, and you actively ignore me. I'm really sick of it. I could just pull out the test from 3 years ago. Instead of doing a project, we could go back to paper tests, where you calculate this stuff by hand. We don't use software, we don't do projects. We just sit here and take notes and do paper. Or you could listen to me, let me get through what we need to get through. You have time to work, time to do stuff on your computer, time to talk to your friends, but you get through what we need to get through first. We don't sit there and chit-chat the entire time. I'm trying to show you something that you need for your test. I am sick of it. So, look at these and see if we can figure out what it is we could do to try and figure out what we need to sell our car at. How could I figure out the price of my car? Or is there something that would help if we need it to find that? What would be something we would wish we had in here to find what we want to know? Yeah, it might help if we could have a line or something. So if we actually come in here and we put, lives in plotted value. No, not plotted value. Where is my movable line? Click on movable line. And click on the ruler and then click movable line. And what I want you to do on both of your pictures in here, I want you to drag this around and see if you can find the best line that's as close to as many points as you can for both pictures. See if you can come up with a line that looks the most accurate. Mia. I didn't forget. Just wound up on a rant. All right, so going through here, get as close as you can to your, what you think a line of best fit would be. And then I'm going to show you a tool you can use to actually get it even closer. If you go into your ruler and you click on the box that says squares of residuals. I know we don't know what that means. But what that does is that puts a little square between each point and the line, and it shows you the number. It says sum of squares. And what you want to do is you want to see where we can put our line that gets it with the smallest number. I want the smallest number of squares of the residuals. So click on the squares of residuals and see if you can manage to get it as small as possible. Because we're trying to do this by hand. We're trying to eyeball this. Back in the day, we would draw these all by hand, and then I'd bust out the box of uncooked spaghetti. And we would line it up as close as we could get it. Doing it by hand. So see how close you can get your squares of residuals. And see what's the smallest you can get that number. Because what the squares of residuals shows you, it shows you how strong it is. The bigger the number, the weaker your correlation is. The smaller the squares of residual is, the stronger your connection. Look at the sum of squares number and see if you can make it as small as possible. For age versus price. Oh, you're moving up.
Yeah, because they were getting in my way.
Yeah, you can move the little box out of the way. We're just trying to find these pieces, and each of these little squares does something different. So some of them move our slope. This one changes my y-intercept all by itself. This one changes my slope again, but it keeps my y-intercept the same. This one keeps my keeps that point as close to the original. So what is about the smallest you get in your sum of squares? Mine's about 127 million.
So that one, mine, 126.
Oh, you got your 126? You're better than mine. 125. Anybody less than 125?
I also beat you on the other one too. Mine, that is 170.
Awesome.
13.
So what that's doing for us is it's showing us our equation right here. And what we're doing when we're trying to find our sum of squares, you see these little blue squares that are all over the place here? And when I move this, some of them get bigger, some of them get smaller. That's measuring how far from the line each of the points are. So it's doing kind of a distance this way, but it gets all geometry and weird. And the reason they have them as squares is so it doesn't matter what's above, what's below. That makes them all positive values. That's the only reason we care about the being squared. So what our movable line does is it lets us play with it and try and get it as close as we can as humans. Or we can say, computer, please do this for me. And we can click on